What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another one of our regular streams where we try to get together and hack on something, usually from scratch and usually with a lot of problems along the way. But I mean, that's just sort of the nature of the beast whenever you're trying to build things on a live stream while people are looking over your shoulder the whole time. So first of all, I want to say thank you to Bill Scherer for being here. It's tea time, Bill says. Well, I just made myself a nice cup of coffee, so we're going to be enjoying our caffeinated beverages together here. Today I have the pleasure of trying to stream with a cold that's coming on, which is really nice. You know, if you have a kid that's going to daycare or, you know, the early ages of school, you know what it is. Basically, the kid just brings home any kind of sickness that they catch from the other people there, and you got to deal with it. So that's what I'm doing right now. I'm just trying to fight through the oncoming symptoms and try to go ahead and get this stream going. Hello to Jackson. First time catching this live. Listen to all the past streams over the last week. Wow, that's a lot of streams. Thank you for watching all those. I'm curious to see what you thought about it, going through all of it and seeing sort of the meandering path that we've been taking through this project. I promise that you know, there's actually, you know, a plan. I just happen to take a lot of, you know, tangential paths along the way that eventually fork back into the main approach. Bill seems to know what I'm talking about. Yeah, it's always fun whenever you have kids bringing home, you know, multiple colds every season. That's fine, though. Let's see. Yeah, okay, good. The restream bot is working. That's great. Is it duplicating all the messages? That's really annoying. I got to get my my bot situation fixed here, obviously, but hopefully it won't be too annoying. Okay, so today is another little tangent that I went on the last week, and it's part of the reason why I didn't do a stream on Thursday, because I was so, like, amped up over the project that I worked myself a little bit too hard and was kind of dying out of tiredness on Thursday. So I took that day off, but I'm back today, and we're going to talk about what I've been working on over the last week. Hey, Fade. So this stream is about compiling Mesche to bytecode. Jackson says, I like how you change your mind about the project, makes me feel less bad about doing the same. Well, that's what you'll see me do a lot on this channel. I'm sort of opening up my own personal process to the public and showing the fact that I actually do sort of rethink things quite often. And you know, it doesn't make good for if you have users, but I don't have any users, only myself. So it's totally fine for me to do this. But I don't recommend doing this in a professional situation, I think. So today's goal will be to wire up the new Mesche compiler to Flux Compose and start building APIs for it. And we'll expand on that idea a little bit also, because maybe what I came up with initially is not exactly what I would like to do, but we'll talk about what Mesche is in a moment. First of all, I wanted to point out that we're actually using a thumbnail generated by Flux Compose for the stream today. I don't know if you noticed it, because it looks pretty much the same as the previous thumbnails, but that's sort of the point. The stream last Tuesday, we actually managed to get code working to generate that thumbnail by the end of the stream. It's very, very hacked together, and there's a lot of bugs in there. But it did work well enough for me to go and generate the thumbnail for today's stream with it, and I was able to upload it to the stream schedule, whatever you want to call it, on YouTube and on Twitch. So the file is good enough for use in you know, my purposes of creating videos, which is great. So we've at least hit like the first basic milestone of what I'm trying to do here. You know, trying to build a set of creative tools for me to create the things I need for my own projects, you know, just videos and streams being one of those. So I'm very happy that we were able to hit that milestone finally. Hey, Gun. I feel like that's like the first major achievement. I know it's not very major, but we have taken quite a path to get there so far. So thank you all who've been here the whole time, who've been watching this and cheering me on, and also providing help from the sidelines, because it's been very helpful. Also, I want to say thanks to Ashraz for debugging the memory corruption issues that we were seeing at the beginning, or I guess all the way through the last stream, where we would, you know, keep restarting Flux Compose, and half the time it would crash with some strange error regarding malloc or something else. Ashraz went and turned on the address sanitization compiler features to sort of track down where it's all coming from. And of course, it's coming from all the crappy code that I wrote for the last iteration of the scripting language. I was doing some very sketchy things with memory layout because I was trying to be efficient. And now I'm realizing how stupid all that was. This is what happens sometimes. You know, you're learning how to do something and you just make a mess of it first, and then you go and do it again, and it's much better. So today we'll be talking about how I'm repenting for those sins, but we won't actually need to fix that issue today, hopefully, based on what we're going to be talking about. So I appreciate Ashraz looking into that, and I will be using the stuff that he did to diagnose that issue, because obviously we're writing C code here. These kinds of issues show up all the time, so it's good to have a way to diagnose them whenever they do show up. It seems like it's a pretty good way to do things without having to use something like Valgrind or Valgrind, however you pronounce that, to do memory analysis. You can just have the compiler inject some stuff into the binary to detect whenever you're corrupting memory or writing over stuff you're not supposed to be writing on. So pretty useful. I'm liking it. Hey, Vladislav. So today we're going to be talking about Mesche. Now, when I started working on a scripting language for Flux Compose, one of the things I said in the stream where I sort of announced that idea is that I was not going to be building a general purpose scripting language. I was going to make something that was more meant to be a declarative language that will be driving the C program. And we're still going to basically have that. Hey, Daigo. But we are going to be expanding into the general programming language space now also. And this is because I read the really, really excellent book, hey, Emil, called Crafting Interpreters by Robert Nystrom. I would say it's probably one of the best computer science books that I've read ever, because it walks you through two different implementations of an interpreter for a toy scripting language that the author creates in the book. And the first implementation is in Java, where it's just like a straightforward interpreter where you're parsing into a syntax tree, and then you're just evaluating based on that syntax tree. The second part of the book, which is actually most of the book, is writing a bytecode compiler for that language in C. And that's exactly what kind of thing I needed for this project, to learn how to write such a compiler so that I can extend what I'm doing to make it more useful. So over the last week, I've been following that book very closely, basically just typing in the code samples directly and then adapting them, because what they're doing is a language that's sort of like a Python or a Ruby with lexical scoping and a little bit of extra stuff on top. But I wanted something more like Scheme. So I just took the examples in the book and adapted that to a language that is very much like Scheme. Gun guessed it first. Mesche is definitely Scheme with transposed syllables or transposed letters. So if you just shift the characters of Scheme over by 2, then you end up with Mesche. So that's... I'm giving my my hat tip to Scheme, because to me, I feel like Scheme is like the purest and most interesting language I've ever seen. When I say that, I mean like the actual core of the language. Maybe another time I'll get more into detail on what I mean by that, but I feel like it's like the purest basis to build on top of, especially when you have macros and syntaxes and stuff. So I am doing my own Scheme-like language with a compiler, which compiles the bytecode, and it will not be based on Scheme directly, but it is very inspired by Scheme, and you'll see that whenever I start showing some of the code samples of what I've got working so far. So Mesche is the name of a Scheme-inspired language that I've been working on in various forms for a year or so. If you were watching System Crafters last year around this time, I got the idea to write basically a Scheme to native code compiler, just write out x86 assembly or x86-64 assembly directly, which obviously is an insane idea because it requires a lot of work. If you're really going to write out assembly directly and then try to write your own linker to link to applications, which I had intended to do, that's a ton of work. And I was able to make some progress with that, but obviously, that language does not exist right now. So I had to put it on the back burner because of other things that were coming up. But it's always been something in the back of my mind. I'll give you more context in one sec. So the reason why I wanted to do something like that is because I had been writing a lot of code in Scheme the previous year, and I love Scheme. I think it's a great language. But the more I started looking into high-performance code, specifically around game development, which is what I was focusing on at the time, I realized that having a garbage collected language that is based on dynamic types is not necessarily the most efficient thing if you want to do data-oriented programming, and that's basically writing code that's very cache-friendly. Now, it may be possible with certain Lisp or Scheme implementations, maybe Lisp implementations as well, but At the time, I didn't think it was possible, so I started spending a lot more time writing code in C, but I still really wanted that that really nice language like Scheme to be able to craft my environment more the way that I want it to, have low-level primitives that I'm building on top of using my own macros and basically just creating my own environment to play with. So the idea with Mesche was to try to build a compiler that would get that, native code benefit, and also maybe have some affordances built in to produce more cache-efficient data structures as well. Because if you're using linked lists, which is basically what the default data structure is in Lisp or Scheme, then that's not very cache friendly unless the allocator has been very kind to you and allocated your const cells right next to each other. And even then, your const cells are having pointers to other locations in memory. So point being, I wanted the language like Scheme, but was more attuned to writing more high performance, low level code, like basically a Scheme system programming language. So I put that on pause for a while, but lately when I've been thinking about this Flux Compose project and all the things I have involved here, I really did want to get back to having a full featured language that fit those ideals that I had for a language. And when I started reading this Crafting Interpreters book, I actually felt like, wow, that's actually something I could probably do myself, because the book explains it end to end, and the implementation that they have in the book seems to be quite efficient and uses what seem to be best practices for writing a bytecode compiler and interpreter based on that. So I'm going to go down this path for a while and see how it goes. But I'm really excited about it because it was a lot of fun to write, and I feel like the code turned out pretty good. So we're going to talk about that a little bit more today. So the new plan for Mesche is to use Mesche as a C native scripting language, which basically means to build on and work well with C and leverage it fully instead of pretending to build a separate language and environment on top of it. So many of the Scheme or Lisp interpreters that you see, they're their own environment. Now, you do have the ability to use foreign function interfaces to call into C code and interact with C code pretty well. Many of them have very elaborate abilities to create bindings to C code. Gambit Scheme in particular was pretty interesting because when you compile a Gambit application, you're compiling it to C, and then the C compiler takes care of compiling the final binary. So what you could do there is write your bindings in Gambit Scheme and have those get turned into C code. So you have your own sort of intermediate layer that translates between Gambit and your C libraries. So you don't have to write your own shims. And that's kind of a powerful approach, I think, and it's something I plan to do here as well. So instead of trying to make a language that I'm writing all my programs in solely, what I want to do is make a language that works extremely well with C, so I can write applications in both languages. So where a good portion of the low-level components and high performance areas are all written in C, and then we have the Mesche layer to drive all of that and also have a better programming model built around it. So the way I see it going is that you would basically have Mesche be the entry point of the application. It would call into some C functions to allocate all the stuff necessary to run the app. And then from that point forward, you could send commands to it through a REPL or run any arbitrary scripts you wanted to run, and it would interact with that lower level C layer, which is effectively what we've been talking about this entire time since I started making these System Crafter streams, Flux Harmonic streams. Basically, the goal is to have Scheme effectively be the control layer for high performance C applications. So we're still heading that direction. We're just taking yet another approach to it at this point. So like I said, it's not meant to be a full standalone environment. It's actually going to be a hacker's tool for writing better C programs. So the whole point is to create C programs, but we have this really nice language to use with it, and also a tool set that I'm going to build along with it as well. So that you may be asking, what makes it Scheme inspired? Well, there's some pretty fundamental aspects of Scheme that I am using here. First of all, we would have first-class functions with lexical scoping and closures, and that's a big deal in in Scheme because functions actually are like the core of a lot of what Scheme does. They really use functions to the max when it comes to building abstractions. And when I say that, I mean like things like a let statement. I think many Scheme implementations will compile a let expression where you're creating variable bindings into a self-evaluating function call that passes those values in so that you get that new scope. I'm not going that far yet, but that's sort of the angle that I'm targeting here as well. I'm going to try to experiment a little bit to see if that kind of code is going to be performant enough. But I like that idea that you're really making functions like the core primitive of abstraction in the language, and taking it to the extreme. Also, the language is intended to have a minimal core that you can build on using modules and macros. So the actual core language that you integrate into your C program would only be the necessary primitives for executing code. Everything else should be modules that you can pull in from separate repositories potentially, and then compile into the application as well, or load them up dynamically at runtime. So there are going to be Mesche modules that are either written by me as part of the Mesche project or by other people, whoever, that will have Mesche code plus C code, or maybe just C code with Mesche bindings. So the idea is that the tool chain for Mesche should be able to dynamically pull code from Git repositories to build into the project and make it part of the code of the project. And that's not really a big surprise if you use languages like Dino or Go. It's becoming a pretty common pattern now where you're expressing your dependencies as links, effectively, or URLs to Git repositories. So we're going to try to bring that same idea forward in this language as well, and we're going to have to build some tooling to make that possible. Also, we're going to be using tail recursion for looping. So that's not implemented yet, but it will be soon. I'm pretty sure I understand how to do that now. If you don't know much about tail recursion, basically it's just a way for the compiler to identify that when a recursive function calls itself, if it calls itself in a certain way, basically where the self-referential call is the last expression of the function, it can, instead of making that a function call, turn it into a loop instead. So it basically just jumps back to the top of the function, takes the new set of values for the original bindings, and it just keeps running. So it's a very effective way of writing loops, and you can write basically any kind of loop with that pattern. So the common thing you see in Scheme is this idea of a named let. And a named let is a let expression that has bindings, but it actually has a name along with it that can be called inside of that body of the let expression. So it basically turns it into a recursive function, and you can use that for looping. And I was doing that quite a lot whenever I was writing Scheme code in 2020, and I liked it quite a lot. I thought it was a pretty cool pattern. And, my sort of desire for minimalism sometimes really appreciates it whenever you have one or two ways of doing many of the things that you would want to do. So in this case, you have this tail recursion construct for looping that allows you to do basically any kind of looping construct you want. If you're basically using functions for everything, then that just means, okay, I'm just thinking in terms of functions. And I don't know, it makes more sense to me as a person who has spent a lot of time doing functional programming, and also using Lisps and writing macros that wrap stuff like this to provide higher level constructs for defining stuff in code. So I'm very excited about writing the tail recursion functionality so we can use that for all the looping constructs, which we don't actually have yet. I don't have any looping constructs because I'm waiting to implement tail recursion for that purpose. So that's one thing we can't really do right yet. We might also implement continuations in the future, but I think that's going to add additional complexity to the code, and I kind of want to keep the code simple. The reason why is because one reason to write your own language implementation for the purpose of a project is so that you understand everything that it does. And that's fine for me. Whatever I write in here, I will understand it because I wrote it. But if anybody else is to try and use Mesche, which, I don't really intend for that, but if people decide they want to do it, I'm not going to stop them. I would be happy to have the feedback. I would want them to be able to look at the code and understand it as well. And I think that continuations are kind of the tipping point where the code becomes a lot harder to understand. But that's sort of an assumption I'm making, and I don't know for sure because I haven't written a continuations implementation yet. And to roll back a couple steps, if you don't know what a continuation is, it's basically, well, in the Scheme world, continuations are a way to compile your code where instead of having functions that return things, every function, its last parameter is a pointer to the next function to call. So instead of returning from a function, you're calling the next function and passing the return value to it. So this is a completely different execution model, and it allows you to do very interesting control flow constructs where you can implement things like asynchronous calls or channels or many other high-level features you see talked about in other modern languages these days. You can do it very easily in Scheme because of this construct of continuations. However, they are kind of complex and mind-melting if you don't really know much about them and you're trying to look at code that uses them. Now, a good compiler doesn't make you think in terms of continuations. Most of the time, you're just writing normal-looking code, and the compiler converts it into continuations for you, which is basically what this compiler would have to do also. And because of that, I'm considering holding off until it becomes clear that they would be a major benefit. So for now, the idea would be to, instead of trying to use continuations for maybe concurrency, I would just use multiple threads. So I would have VM per thread, or VM for the language per thread, and be able to communicate between them. So a little bit more of a standard way of doing this. Jackson says, I'm in CS 101 now, and this is talk about writing your own language is very motivating. I'm excited to learn more. Yeah, computer science classes in college are not very interesting until you decide you want to do something like this, and then they become very interesting because there's lots of interesting problems that you can solve by doing these things. All right, so let's say a couple things about how this is not going to be Scheme inspired. I do not intend to make it possible to use standard Scheme SRFIs or SRFIs with this language. And if you don't know much about Scheme, Scheme is kind of like a core language specification. In the previous specifications, like RR5, RS, and before, it was kind of like a very minimal subset of what you need for building things. And then there was a collection of additional specs written by the Scheme community for additional features that you might want to load into a Scheme implementation. And the idea is that if you implement the R5 RS specification to the letter, then if you take code written for one of these SRFI implementations, you should be able to run it in your Scheme implementation and get extra functionality that you didn't have by default. This has been used to varying levels of success, and often you'll see SRFIs written that have customizations for different Scheme implementations because not all of them are the same. They all have different implementations. Because Scheme is sort of a spec and not a single language implementation, all the implementations are different in their own ways. So SRFIs are a great idea in theory, but in practice, I'm not sure how great they are. So in my case, the language is the language. We're writing a language that is meant to be self-consistent, and any kind of cool features we want to add to the language will come in through modules written for the language, and with only this language in mind. So that the purpose there is to make it so that things can be more efficient, because we can drop down to C to do some parts of the implementations we want to, and not have to worry about making the language conform to the Scheme standard to work with these things. And that goes into the next thing, which is this language is not going to follow any of the Scheme standards to the letter. We're taking direct inspiration from some of the core syntax and core constructs, but it's not going to be a Scheme that would fall into the family of schemes. It's more like a derived language from Scheme. And this gives us the freedom to specialize. It gives us the ability to decide whatever it is we want to do that works for the types of projects we want to write here. So we don't have to have the same APIs. We don't have to have the same execution flow or evaluation semantics or anything like that. We can do whatever we need to do that works best for this project. So as you see me saying over and over in this channel, we're writing things that work for exactly what we're trying to do, and not really trying to generalize for everybody, because it's more fun to try to focus on writing cool code that does what we need. All right, so let's talk about what actually works in the language so far. It does compile directly to bytecode running on a custom VM, and this is all in one code project. It's surprisingly not so hard to do this. I mean, thinking about writing a language that compiles directly to bytecode and then has a VM that runs it sounds like it would be very difficult. But if you have a good resource that tells you how to do it, then it actually isn't that difficult, and it makes a whole lot of sense. And I can show you a few things about that I learned that motivated me to keep going, because I felt like, oh, okay, so this is not like some huge mystery. This is not something that's only for graybeard wizards. This is something that I can do too, and I can actually maintain it myself and do exactly what I want to accomplish without having to spend a whole year making a language. Like, I've got something working right now that could be good enough for what we want to do. First class functions with closures, that does work right now. You can define functions. It doesn't have the exact same syntax for definitions of functions as in Scheme, but it does actually use more of the spirit of that, which we'll see in a moment. And closures do work. If you define, or if you create a lambda inside of another function, it will capture the locals and carry those forward to be used whenever that function, the inner function, gets called if you return that function out. So you can create closures at this time. The implementation for that is pretty cool. I might have to explain a little bit more about that. Native function registration for integrating with C APIs, hugely important for this project, and it does work right now. You can actually register basically a function pointer with the global scope of the VM so that you can call into that function from the Mesche language, which is great because we need that immediately. It also supports running in a VM per OS thread. I've written it so that all the functions require you passing in an instance of the VM. Hey, Ashraz. So you, in theory, could have thread local variables for that VM object and then run the language on multiple threads. Now, we haven't thought at all about how to pass things between those threads or any kind of synchronization primitives or anything. That will come later if it's necessary. But for now, I'm not going to worry too much about it. I just made sure to design the code up front so that it would work in that case. Also, I've got garbage collection mostly working. We're using a mark and sweep algorithm. It's what's being explained in that book. And I mean, I think it's going to be good enough for now. I think that, I'm going to get the core language working using what the book describes. And we're going to try it for a while, see how it goes. And if there's performance issues or problems we run into, we'll try to make improvements along the way. But for now, the core stuff is good enough. I think we can actually start using it immediately. What comes next? Unhygienic and then possibly hygienic macro definitions. So macros are a huge part of any Lisp-derived language, and we're going to use that to full effect in Mesche. When I say unhygienic macros, I mean something more like def macros. Yeah, Ashraz, the bot is being a little bit overzealous there. I don't know why it's doing that. Sorry about that. So unhygienic macros are like def macro in Lisps, where you just sort of templatize your output code using the macro function. And the reason why they call it unhygienic is because it's very possible to capture symbols in the wrong way inside of the macro output and shoot yourself in the foot a little bit. But in practice, I haven't really run into a whole lot of problems with that. So I'm okay with having unhygienic macros first. Scheme has hygienic macros, which are more like a pattern language for describing the output of the macro. And I think that they are nicer, but they're also probably harder to implement in a compiler. So we're going to start with unhygienic. And if it turns out that we need hygienic macros, we can go back and add it later. Also, we're going to build out the standard library of things that need to be added to use this as a real language, which things like file IO, APIs for manipulating file paths or files themselves, process management if you want to launch a process, get the output from the process. All these things will definitely be necessary. Ashra says you can implement hygienic macros on top of unhygienic, but not the other way around. That's at least what I've heard. Yeah, it might be possible. I mean, if you use gensims, then maybe you could do that. You could write hygienic macros that then use gensims correctly to make it possible to generate output that does not have these capture issues. Defining code in modules that can be loaded into Mesche projects. This is going to happen pretty soon because, to make this language useful, we're going to have these modules that can be pulled in. And I really want to figure out the whole module system approach. I have a pretty good idea of how I'm going to do that, but I just haven't got started on it yet. And some of the other stuff that we're going to work on will be very important to that as well. Defining structure types in Mesche, not hugely important, but it could be interesting to see how that's going to work, especially how those will be read by C. The book that I'm reading does go into how to define classes and have fields on classes. So that's probably the place where I'll try to get some insight into that, and I might end up implementing basic structure types in Mesche using that information. We may also try to do some things like protocols or like the what is it called? CLOS, like the common list object system, where they have dynamic dispatch for operations on particular object types. We might have something like that too. One of the things that kind of is annoying about Scheme sometimes is that you have to have individual functions for operations on different types. So for instance, if you want to have like a map function, map can only work on list types. And if you want to use that on a vector type, you have to use like a map vector or something. So we'll think about that later. It's not really important for right now. Star 7 says, interface you mean? Yeah, I mean, you could think of it like an interface, but since this is not a typed language or not a statically typed language, then interface doesn't really mean as much. It's more like a way to define a single method that works across multiple target types. So it's more like what Go has, I would say. Let's see. Define bindings to C functions and structures in Mesche code and generating the C bindings at compile time. So to integrate with C code is nice if you have the ability to not manually write all of the bindings to the C functions you want to use. So it'd be nice if you could define those bindings in Mesche in a very convenient syntax and then have it generate the C code that does all the wiring for you that you can use to compile into your application. So that's something we will definitely look at. The idea being that the compilation process of your code for your project would call into the part of the compiler that generates those binding files before it runs a C compiler, and then it will compile everything and then run the whole project and then load up your actual Mesche code that uses it. APIs for working with dynamic arrays of C structures, especially for cache friendliness. That's one of the big deals for what I want to do here. I want it so that in Mesche code, I can deal with tightly packed arrays of information in C that was defined in C basically, or allocated in C, so that you can get to struct members of an array or a vector basically, and not have to have like a box representation of that in the language. So you don't have to have like an object in the language that wraps each individual object and then has to point to different locations on the heap. I want an actual direct access to an array that I can index and then read stuff out of those entries. Gun says CLOS is in common Lisp. Yep, that's right. Guile has something called Goops, which is similar, I think. Cross-platform build orchestration, dependency management, and release builds with Mesche build. Now, this is actually kind of a big part of the project, and one of the core reasons why I wanted to do this. Having a build tool for the project is able to orchestrate the whole process of pulling dependencies, compiling them into your project, compiling your project for different release targets, etc. It's something I was working on when I was building games with Gambit Scheme. I had sort of written my own build logic for that, so I could do cross-platform builds, pull in all the dependency files, everything, and just package up a final binary that could be used on multiple systems. I would like to do the same thing here, but make it a core part of the language so that the main compiler command you run for Mesche has a build subcommand that's able to do all this stuff for you, and it basically just starts from a package definition, which I wonder if I deleted that somehow. But anyway, it's gonna be pretty cool, I think. Fade says build tools are a surprisingly complex, deep subject. Yeah, we'll decide how far we get into that. I mean, we could shell out to Cmake, or we could decide to instead of using make files or anything like that, maybe invoke GCC or Clang directly, which is a terrible idea, obviously, because you lose a lot of benefits of Cmake, etc. So that will be decided later, and I'm definitely open to feedback on the right way to approach that. Also, in the far future, which is not going to happen anytime soon, native JIT compilation and creating standalone Mesche binaries. So if you're able to do JIT compilation to native code, then it stands to reason that you could possibly generate binaries based on that. So we might be able to just generate a binary directly using Mesche and then link to C libraries. Maybe, I don't know. We'll see later. For now, like just having it be compiled with a C compiler is totally fine. Star 7 says, what about testing? Yes, well, testing is going to come very soon because I need it. I need to be able to run tests against this compiler because I have not written any tests so far. And I credit that to the author of the book, Crafting Interpreters. The code there worked so well that I didn't have to write any tests because it just worked. Now, I'm going to go back and write a whole bunch of tests. And I think what I'm going to do is one of the first modules I'm going to make is a testing module that allows you to write your tests in Mesche and possibly even call C functions and test those as well. So writing tests in Mesh would be easier than writing tests in C, I think. We'll see. Ashra says also integration testing for the C interfaces. Yeah, you definitely need that as well. You absolutely would need that. Okay, so today's tasks. First of all, we can try to wire up our existing Flux Compose APIs to see if it works. I've sort of already done this, but I haven't done it with the functions we've been defining for things like showing the preview window, etc. So we can quickly try to do that just to see if it works, and then move on to the next stuff, which would be adding some standard library functions to enable building with mesh build. So one of the things we need sooner rather than later is this mesh build command, because right now the code for mesh itself is baked into the Flux Compose repo, and I don't want that. To split it into another repository means it's going to add a huge amount of complexity to building this project. It is possible to use Cmake to pull in external dependencies, and I haven't figured out the right way to do that yet. I might have to do it in short term, but I do want to split these repos because I feel like it's kind of weird to have a whole language implementation as a subfolder of some other unrelated project, or seemingly unrelated. So setting up mesh build could be a way to get started with that, and it also sort of creates some requirements on some standard library functionality like resolving paths or loading files or shelling out to subprocesses and stuff like that. So we can start doing some of these things as well. And then maybe we can delete the old scripting language code that is totally problematic and not really good. So if things seem to go well, then we can just delete that code, but maybe we won't have time. I'll also mention that it's probably likely that I'm going to do a lot of work on this language and tool set off stream, because it may not be very interesting, some of it. So if you want to see more of it on the stream, I'll be happy to do more of it, but I didn't want to just sort of like be focused on compiler tools for the next few weeks. I want to sort of mix things up a little bit so that it's more interesting. So I'm going to be interleaving certain topics. Like today, we're going to be talking about the compiler, maybe also on Thursday, and then next week we'll definitely get back into more of the graphic side of things so that we can start to polish our output. But maybe by then, the stuff we've been working on with Mesh will have moved us far enough along that we can stop writing all of our rendering stuff inside of temporary C functions and then use Mesh to drive some of that behavior as well. So I'm kind of looking forward to that possibility. All right, so let me actually show you some things first about the language so that you get an idea of what it looks like. Because I've been talking for 40 minutes about it, but you haven't seen any code yet. I've got a few sample files. If you go to the Flux Compose repository, which is github.com/fluxharmonic/flux-compose, go to the compiler branch. You can go into the lib/mesh folder, and that's where the whole compiler implementation is. I've got a bit of a README here that says a lot of the same things I just told you and has all the source files there. So if I go into that folder, you can see that I have a source, and I've got a few different files that have all the implementation details for various different things, which we'll get into in a little bit. And then I have some samples. So I don't know how clean these are at the moment, but it basically looks like Scheme. If I run Scheme mode here in Emacs, this is just basic Scheme code where you have like a let binding expression to bind A and B. You do some operations on it for addition. You can print out the results. I don't have the ability to print new lines yet. That's obviously something I can add really easily. I just haven't done it. But I could run this thing if I were to compile the project. So let me go to the console and pull up, let's see, Geeks shell. Let's just start there. Okay, so we're in the shell, and I'm gonna run make -c build. All right, so we're building the project. In theory, it should work. Okay, so it seems to have built fine. Then build/flux compose, and then I'm gonna pass in a path directly to that sample. So lib/mesh/samples/ what's it called? locals.msc. Oh, segmentation fault. Probably I made some changes that broke the specific example. Taking a quick look to see if I could divine what the problem is. Let's look at a different one maybe. This is the problem making your own compiler, folks, is that you could definitely break something in the time between you write things and the time that you show it to people. All right, let's try the closures example because I worked on that most recently. All right, so that one works. So what we have here is the ability to define closures or create closures. And I'll explain a little bit what that means right now, I guess. So we're defining a binding in the global scope called outer, and then that's going to have a lambda function in it. So this is typical scheme syntax for defining a lambda function. We're binding that to the name outer. And because scheme is a Lisp 1, or basically the function definitions and variable definitions are all in the same namespace, we can just assign a function object to a variable and then invoke it, which is what we're doing right here. We're just calling the outer function here. Now inside of outer, we create a binding for the name x to a string called go, and then we return a lambda out of that let binding, which is basically a function that calls display on that value x. So here when we call outer, we're creating this lambda function and returning it, and then we're assigning it to inner. So now inner has this lambda function, which has captured the value of x, and now we can run inner 3 times, and then that will give you the output you see here at the bottom, which is go, go, go. So the language works enough to get to that point, at least, which is good, because if you have closures, you have the ability to do some level of abstraction. We also have the ability to define functions using just pure defines of variable names to a function object. So that's enough to start building a little bit of an API. Let's see, what else we have? Functions.msc. Let's turn on scheme mode here. This is another example of a few different things. Let me try to run this one as well. So functions.msc. So it did work. I don't have new lines like I mentioned, so you'll have to see here at the very bottom, hey, 15 self-invoke, and then some floating point number. So what's happening here is that I've defined a function called myLambda, which takes 3 parameters, a string and 2 numbers. So I display the string, then I display the result of adding those 2 numbers together. So when I call that with 5 and 10, we add it together, print it out, no big deal. We also do a self-invoking function here where we have a lambda function object in the first position of a list, which is the call position, and then we pass the value to it. So this sort of proves that we can do scheme-style function invocation if we need to for things like let bindings, etc. You basically just have a compile out to a function object and then pass arguments in it to create a local scope without giving the function a name. And here, this clock function actually is registered. It's calling into the actual C time functions to return the number of ticks since the since the process started. So it is proving that we can actually call into C functions from the VM. Anything else interesting? We have define, we have conditionals. We do have the ability to do like if statements and stuff. I wonder if this one's going to crash too. Some of these I haven't worked on in a few days. All right, conditionals. All right, so that one seems to work. So I'm doing an if. So or nil or t, which should be true. Then it's going to go to the 1 + 3 path, which returns 4, which is what we see at the bottom here. So conditionals, basic conditionals do work. I don't have short-circuiting working yet. I need to do that. It requires compiling to some jump instructions and whatnot, which I just haven't gotten back to. But I'm happy that it does work, at least. And you might be noticing that there's a lot of output here along with the running of this code. We're actually writing out the disassembly, effectively, of the bytecode that I've written out for this function definition or for the script. So you can see all the operations that are occurring in the execution. There's also a flag I can set to show the actual stack of values as I'm executing, which is pretty helpful for debugging. Hey, Alvaro. So it is pretty nice to have that as a debugging thing. And I didn't come up with this idea. That was part of the book. So if you think this looks cool, definitely go read Crafting Interpreters. Excellent book. Like, unbelievably good book. I can't speak highly enough about it. Yeah, read this book and you will be able to do exactly what I did. So let's see. That's enough for the examples. I'm kind of curious as to why this locals one crashed. Let's see. I'm not going to worry too much about it right now. We could debug it, actually. Well, let's try it. We could just run it through GDB. So let's grab this line here. All right, good, GDB. I'm just curious about what's happening there. So we will run the program with that path to the, no, not conditionals. We want to use, what was it, locals? Locals.msc. Wow. Okay. So we're going to run it. Okay, so read byte is giving me trouble. Oh, okay. Probably some of this stuff I'm doing with pop scope has screwed me. Interesting. Check the backtrace. Eval string. Okay, so it's just in the run. I'm trying to read the byte, and probably it runs out of space. Okay, I'll fix that another time. Not a huge problem, unless it stops us from doing things today. Okay, so then now, let's go take a look at the code really quickly. I'm not sure whether it's better to look at the compiler first or the VM first. Probably the compiler. Let's go to lib mesh source, and then compiler.c. So in this file, there's a lot of stuff. It's about almost 700 lines long, but it all starts from this mesh compile source, where you basically give it a VM object, which we can talk about in a moment, and then the script source that it will parse through. We create a context for compilation, and then we just set it off on parsing what's in there. So we're not parsing to an intermediate AST, we're parsing directly to bytecode. So we read in all the tokens, and then as we see them, we're just writing out bytes to effectively an array that allows us to encode all the operations that we are running. And it seems like that would be difficult to do, but it's not really, especially with the way that the scanner is implemented in this project. So the scanner is basically the tokenizer, and the implementation that he came up with is way, way better than mine. It is, I would say, more memory efficient because it's not creating any tokens on the heap. It's doing it all as values. And it doesn't allocate strings either, because it just holds on to locations of the original string for things like strings or for symbol names, etc. So that while the compiler is running, you're just reading from the original source buffer all the strings out. And then if you need to, you can make a copy of the string. But otherwise, a lot of compilation can be done without even having to hold on to the names of things, just based on the way that the compiler works, which is pretty awesome in my opinion. Way, way, way better than what I was doing before. So this is super simple, mainly because this is a Lisp language and it doesn't really require a whole lot of parsing. You're basically looking for parentheses and the atoms of the language, like symbols, strings, numbers, T and nil. I'm actually going to use T and nil here instead of hash T and hash F like they do in Scheme, because I want it to be a little bit more compatible with Lisp, especially Emacs Lisp, when you're sending forms back and forth through a REPL or for running commands. T and nil made a little bit more sense, and it's more natural to me than hash T, hash F, so we went with that instead. Another kind of interesting thing here is the way that I'm identifying keywords for the language. I basically just have a huge switch statement that is able to identify these things. And probably anybody who's written a real compiler before, it's like, oh yeah, that's definitely what you do. But I didn't know that. I always thought you would just, compare against strings the whole time. So this is definitely much better than what I was doing before. And it made it very easy to add new keywords to the language, like let's say define or lambda, if, etc., and have them be their own token, which makes it very easy to write a parser that looks for such a token and then modifies the compilation behavior based on the token that it found. So pretty cool stuff. Not a whole lot of code. You could probably understand it pretty well if you go read through this part of the code. I didn't really add much comments in here, but probably because I didn't feel like I needed to. The compiler has a lot more comments to explain a lot of what's going on there. So in the compiler, we start with a source file, and then we have these functions for like advancing in the code. Eaglot's not running. So advancing to the next token. So we basically hold on to the location in the token stream, and we're calling scanner next token here, which actually means we do not pre-parse all the tokens. It's an on-demand tokenizer. You ask it for the next token, and it will tokenize it on the spot. So you're not doing a full tokenization pass first and then going through and doing a full compilation pass. It's all happening in one pass, which is pretty awesome. I want to keep that one pass approach as long as possible because it basically means that the compiler is going to be super fast to read in new forms and compile them. So it's kind of a benefit for interactive coding, I think. So let me just show you an example of a specific function, then we'll move on to actually writing something because you don't want to have me explain the entire code base to you. How about a define? So for parsing a define, what you basically do is we're in define already. Let me jump back one layer before. So the call parser is sort of the interesting thing here, I think. So parse list, is that what I called it? Okay. So in parse list, this is sort of the way that we dispatch to a few different types of calling conventions. One of them would be you need to resolve the name of a symbol to get the function for it and then invoke that. That's a pretty obvious one. But you also have two others. One which is whenever you have an operator symbol that it uses the normal calling semantics where you just have parameters that you pass in and then you just invoke the function. But you know exactly what the operation should be because in most cases it has an opcode that gets run in the VM so that you don't have to interpret it at all. So in this case, let's see, where is that? I think it is parse operator call. So we get down in this code where we start looking at all the arguments, and then at the end we sort of look at what type of symbol it is at the head of the list. So here we're sort of looking at the token types to say what type of operation to write out. So these are all things that have their own individual operations that are supported by the VM. And then for special forms, if you know what a special form is, it's basically a calling form that does not follow normal calling semantics. It's basically like the parameters to it get evaluated differently than they normally would whenever you're calling a function. So an example of that would be a define. So you have define, and then you have a symbol right after that. You don't evaluate that symbol to get the value out of it. You're actually trying to set the value of that symbol. So the code that compiles that expression needs to handle those parameters differently than it would if it was a normal function call. Because if it was a normal function call, like if you had a function called define2 and you pass in a symbol as the first parameter, it's actually going to evaluate that symbol to get the value out of it and then pass it in as the parameter to that function. So special form is basically a call that is handled differently than normal calls. So we have the ability to identify those as well based on the symbol or the token keyword basically that we detect when we're parsing tokens. So things like let, set, define, begin, lambda, sort of like the core primitives of the language itself, aside from those operators that you see for things like mathematical operations or equivalence operations. So pretty straightforward, actually. It's not super hard to add new things here, which is great for building out the language. But I think I've got most of what I need, at least for the starting set of stuff, that now everything else can be added as either native C functions or maybe Mesche functions that we've written. The VM is kind of interesting in that the whole heart and soul of executing this code is in this one, what is it called? Mesh VM run function, which effectively just loops through all of the instructions that are in the array of bytes for the current function that it's executing. So for each one of the bytes that it reads, we have this massive switch statement that looks to see what the byte is and then acts on it. And I won't go into sort of the implementation details of how the VM works right now. I could definitely do that if people are interested on another stream maybe. But the idea is that this is a stack-based VM architecture where whenever you have values that you need to get passed to a function, they get pushed onto a value stack. And then when you call a function, you pop those values off the stack to execute the function, and then you push the result of the function back on the stack. So you have this stack that keeps getting built up and then consumed as the code gets executed. That's different from a register-based architecture where you have individual registers where you have to stuff values into before you call a function. Stack-based is a lot easier, I think, because you don't have to know which registers are available or change which registers you compile to on different platforms. Stack-based architecture is a little bit more consistent and regular, but it's probably not as fast as registers, but it does seem to be pretty fast. So a lot of the operations are for dealing with things like, pushing and popping values and calling functions or operations based on the values that are currently on that stack. There's also things for managing call frames. For whenever you call a function, you have to have a call frame on the function call stack that has all the details about the locals for that function and maybe any captured variables that are from a parent scope if you have a closure. So there's a lot of stuff for managing that as well. This file is about 400 lines. Pretty cool to read through. Very cool how they go through it in the book. So if you're interested in a VM implementation for a bytecode compiled language, take a look at this and let me know what you think. But it does work enough to write sort of, low-level, non-trivial code at this point. So I'm pretty happy with how much I was able to get accomplished in a week of, working on it in my free time. Okay. So now let's actually go to the more high level and look at where I'm hooking this up into Flux Compose, because that's where we're going to start messing around with things a little bit today. So I've replaced the previous code that called into my other scripting language compiler here, where you can see now that we're calling into Mesche VM init. Ashra says a 98 cannot compile in C or C++. 98. What's that? Oh, line 98 in the VM. 98. Oh, right. Yeah, I know. I've got a few of these little issues here and there because I forgot about block scoping for switches. Yeah, you're right about that. Thank you. I'm actually kind of surprised it does work regardless of that. But that's something that I realized recently. There's some of these sort of details about C that I've forgotten over the years, and I'm sort of rediscovering them now. But, when you know more about programming languages, it actually starts to make sense. Especially now that I've written a compiler, I understand much better why this is necessary. All right, so let's see. We'll go back to main.c. Yeah, we set up the VM instance. We initialize it. Then we just evaluate the string that we're reading in from a file or through the REPL. So the REPL is also hooked up, so you could just load the REPL and start evaluating expressions. Haven't run that in a while. Let's actually see what happens if I try to do that. Let's go back into vterm. If I run the REPL instead, I should be able to just do basic expressions, plus 1, 2. Yeah, so it does seem to return 2 there. I can define foo, lambda, string, display hello, and then display string. Okay, so we define a function here in the global scope, and we can say foo flux harmonic. So it does work, which is great. You can go into the REPL and type, actual function definitions and have them execute. So I'm pretty happy with that. So yeah, that's basically the way that we've got it integrated so far. And as you saw, I'm actually running mesh scripts using the compiler on the command line. So I'm running the conditionals script there. So we can actually start trying to write some real code with that. One thing we could try to do is to replicate this, what was it? Examples init.fxs file and just make that init.msc instead. And this show preview window can be a native C function that gets registered into the Mesche VM whenever Flux Compose starts up. So why don't we try to do that and see if it works? We'll go into, let's see, back to main.c. And then let me grab the example that I have of this from, was it vm.c? I think whoa, what just happened there? That's a different file. I don't know why that's showing up. Do I still have those? That can't be right. Oh, I have a couple files that need to be deleted. That's nice. Okay, so go back into source and VM here, and then native, I think I have it called. Yeah, so there's a static function here I can go back into main.c, and I'll define it right here, but we probably will want to move that at some point. And then I'll call this mesh VM define native, grab this and put this into main right after we init the VM. Register some native functions. All right, so mesh define native, I think it was called show preview window. And then this one's going to be Flux graphics. What was it called? Let's go to show preview window. Are you not going to search for me? Ripgrep's not wanting to work. Okay, so we'll go into lib graphics show preview windows. It's this function. I'll have to change this a little bit to correctly use the value types from a mesh. So I might have to actually include that here. Let's go in and drop include mesh.h. Wow. I think that we're going to get some code formatting going on here too, which is going to be annoying. We'll see what happens. All right, so show preview window on this one. I think I'll return a value instead. Value comes from mesh. Yep. Whoa. How'd they go back? Okay. And then also the function is going to take a VM. It's going to take a also a value for args. I believe that's the signature for these now. Let me double check that with Byte. Jackson says, sorry for the off-topic question, but do you have a video for getting the battery time display at the top? We'll cover something like that in the new Emacs from Scratch series because that's part of one of the videos I want to do for it. All right. So let's go back down to, where was it? VM. Define native, and then this function is at the, oh, actually, we have it in main, right? Arg count and then arg. So this is the signature that we're looking for. Graphics.c. We're here. So Flux graphics. Show. Yeah, I should be doing this in the other library, right? So do I have to have graphics here? Yeah. Okay. So let's see. Graphics.c. I'll just grab these. Put this here. Okay. And it's definitely not going to be static because it needs to... Let me go back to VM. I think this is a function that returns a value. Oh. It needs to push it onto the VM. That's interesting. VM stack pop. Where's VM coming from? Oh, it's define native. Yeah, value. So it has an actual value passed by a value. So go back to graphics.c. We're not returning a pointer here. We're returning a value. Now, I can actually try to extract the width and height parameters. I first can check whether it is the right arity. So I can say if arg count is not equal to 2, we can basically say, you know, you're not calling this correctly. I'll just do a panic for now. Probably needs to be a print. So how about this? Flux log. Interesting. I'm trying to think of the right way. This is a binding into the runtime, so it does need to be writing a message to the runtime, I think. We may need to have some APIs for that as well. So flux log, we'll just do it here now. Function requires 2 number parameters. And then once we know that it has that, we can look at the values as basically an array. So args of 0 should be the value for width, and 1 should be for height. And we can try to print that out also. So flux log width, height, and we're not going to keep this. We're just doing it for our own diagnostic purposes for now. Width Now, I think it's like an as number. I have like a macro for extracting these things. Let's double check that really quickly. As number. Yeah, as number. Then as number. In fact, how about we just do that too? Is that returning an integer, I wonder? Let's go to value.h as number. And number is a double. Okay, so we need to cast that to an int, probably. Maybe it'll do it for us if we just say int width, int height, then as number. Okay, so we're getting there. As number. Not really doing any type checking there, probably. Width, height. Okay, and then Flux graphics init, blah, blah, blah. We can put width and height here as well. And in theory, that should work. I could return, I'm gonna return the t value here, just to say that it actually succeeded. And I think that is probably good enough. Let me just grab this now. I'll jump back to space, copy that, go into main.c, and then we're gonna register it here like that. And I think this exported, so it should show up. Let me update that though. So flux.h. Let's see. Graph. Oh, hold on. Show pre. Wow. I don't have that exported. Interesting. Okay. That's fine. If I do this, I'm going to have trouble though. I'm wondering how I can pass this through. What happens if we initialize a graphics subsystem anywhere here? Doesn't look like it. Okay, so we're just gonna do this. How about that? We'll export this for now. I don't think I need all these externs. Now, I've sort of understood a little bit more now about how I'm supposed to be writing code correctly in C, and yeah, some of this stuff is wrong, I believe. Okay, so we got mesh.h pulled in here, which is necessary. I mean, mesh is now a core part of this program. Flux graphics show func show preview window. Okay, so that one seems to be happy now. We're gonna go back to main.c, and this should be happy now if I delete it and paste it back in. VM needs to be a reference, and that should be it. We can try to run it now, or actually let's try to compile it first. We'll run our normal compile command. And build flux compose. We're gonna pass it that examples slash init dot MSC file now. All right, so we got a little bit of an error here. Conflicting types. Oh, flux internal is where that was referenced. Okay, so that makes sense. We'll go to flux internal instead. No. Can't do that because flux internal is not pulled in here. Okay, so we'll delete that from flux internal. We don't want that signature anymore. Show preview window. We'll get rid of that one in specific. Okay, something else. Incompatible types when returning value, but value header was expected. Somehow it still thinks that's supposed to be the case. Ah, yes, script.c. I forgot you existed. Let's see, show preview window. We're gonna not do this anymore. We'll just take that case out. Okay. And it seemed to work until it had our nice lovely little crash again. I'm skeptical. Okay, so it does work. That's cool. So Mesh is actually invoking the preview window now, which is a great sign. Shows us that things are working to some degree, but we do have memory corruption still, and it doesn't seem to be related to the scripting engine. So there's something else happening, and I feel pretty strongly it's related to font config, because I did not have this problem until I loaded up font config. So something about how I'm using that library is wrong. But I'm happy to see that we can replace what the previous scripting engine was doing, because honestly, the way that I wrote that is just horrifying. Now that I know how to do it better, this is just not good. It was fine at the time. It was a good exercise. I enjoyed writing it, but not good. Okay, so what else could we do? Since we have a real language that allows us to define variables, let's see. We had other examples we could pull in. So examples. So basic GFX. We had a few different things that we were calling in here. Keywords are something that I'm going to implement that I haven't done yet, but it should be possible to have functions that accept keyword arguments so that you don't have to pass them in a positional way and the code becomes clearer to read. So that's something that the language will support first class, I think. And the way we will do that is to have the compiler be involved in writing out all those parameters. So basically, instead of having the recipient of the call have to look at the key value pairs and figure out which ones are there or not, the compiler will just write out all of the parameters. It will use the default values for the parameters that are not, the keyword parameters that are not specified, and then for the ones that are specified, it will just use the value that the user specified. So that's going to be a lot better, I think. We just need to get that written, which probably shouldn't take very long. I might be able to do it on a stream, maybe Thursday, who knows. For now, let's see. Given what we have, we could try to do this. Pedro says, how advanced is crafting interpreters? I'm looking for a beginner-friendly book on compiler language design. I would say give it a try. The first part of the book is writing an implementation of the language in Java and doing it in a more straightforward way that's very easy to follow. And it sort of gets you exposed to the ideas of how you would write a compiler or an interpreter. But then the next part of the book where it starts writing things in C, the complexity ramps up a bit, but I still think it's worthwhile to try and go through it because you're going to learn a lot. It's going to be really nice, I think. I mean, for me, somebody who's written a lot of parsers and interpreters before, reading this book completely solidified a lot of things for me that I only sort of knew in theory, but had never seen in practice. So I think that it could, be a shortcut for you if you are interested in this kind of thing and you wanted to learn how to do it. You could, save yourself a lot of steps and just, know a lot of things without having to do study on your own for a long time. Okay, so I'm thinking about what we could do here. So we have the ability to call functions now with strings. I can pull the string out if I want to. This render to file function that we had trouble with so long ago with Guile scheme is much easier now. We could actually write that out as part of the init.fsx file. So we can make a function for this. So long as this launches the window and it renders the first frame, then a function like this right after could work. So how about we do this? I'm going to go into, that init file is not very appropriately named now. So what should we call that? Let's call it thumbnail. How about that? Thumbnail.msc. We're going to drop this in. Let's call it thumbnail.png. We're also going to grab the show preview window. And what this would do is just show that preview window, and then whatever is rendering in it, which we could actually control now probably through this code, we will then tell it to render that to a thumbnail. And I'm going to take this thumb out. We don't really need that right now. It could be that we return something from show preview window that could be passed into this, but for now we'll just keep it simple. So what we'll do is go into graphics.c. We'll create another native function for, what was it called? Render to file. So here we go, render to file. And then we will check the argument count, just, to make sure that it's what we expect it to be. So it's just going to be one parameter for now. Ultimately, it'd be nice if the compiler could do this too, and we wouldn't have to, well, the VM, if the VM could do this also, so we don't have to do it ourselves, but I don't really know, whether that's something it should do. So now Flux function requires a path to the output file. All right, so now we can say char star file path, and then as string. And then what were we using before to render that image out? There was a function we were using here. I think we're going to have to say that we want it to be saved, because it needs to be part of the loop. So it's almost like we need to have an event that we push in, but we're not going to deal with that right now. We're just going to have a flag to say we're requesting that something be rendered. So how about we, let's see, has saved. All right. So that's here. We need something outside. Maybe we could even, let's quickly look at how we can send an event with glfw. Maybe that's a better approach, actually. And we may need some kind of context as well for all this. We'll figure that out, though. I think we have a preview window variable. Yeah, that's right. Okay, glfw event. Let's see. Receiving input events, processing events. How do I send an event? Okay, this is the event documentation, I think. Send? There's got to be a way to send a custom event. Window reference, event. Poll events. Wait events. Yeah, I don't need waiting. I need sending. Let's see. Window guide. Reference. Input reference. Yeah, not helpful. Window reference. There's got to be a way to send a custom event. Let's go to the window guide just in case it says something there too. Event. Window event processing. Okay. See event processing. Great. Wait events. Post empty event. Okay. So maybe there's like post functions. glfw post. Oh, come on. There's got to be a way to do this. Post. I'm going to be really annoyed if this is not possible. It seems like you would want to be able to pass an event in. Scroll input, joystick input. Come on now. Gamepad. Yeah, I don't care about all this right now. Later, yes. Wow, this is really surprising. Event. Event. glfw, how to push custom event. How about that? Custom event carrying a pointer. All right. Set custom event callback. This is real. Post custom. Is that a function? Okay, let's check for this. If this is real. Because that's exactly what we need if it exists. Input guide. Yeah. I don't think it exists. Custom. I don't understand why it wouldn't though. They've got an event loop. I mean, you should be able to use that. Shared event queue. Come on. glfw shared event queue. Ah, okay, so it doesn't. That's really unfortunate. Okay, I guess I could do my own thing if I had to. For now, we'll just use a flag, which is ugly, and I don't like it, but we don't really have a choice. So I can do a module level variable, static. I would put this closer to the function, but better for it to be visible, I think. Static image. Oh, I guess that's a problem though, because you need to be able to tell it what the output file path is. How am I going to do that? Because if it's allocated, then I can't get back to it. It's going to be a problem anyway. Yeah, it's an open issue. Ashraz says the post event function I found is an open issue. Yeah, that's really unfortunate. Like, they have a perfectly useful event loop right there. Why not expose a function on it? Seems a little ridiculous to have to make your own. All right. So to transmit this information, I mean, I guess we kind of do need to have an event queue, effectively. But I don't want to implement that right now. It is something we're going to need. We're going to need some way to communicate from Mesche to the running engine to do something, and an event queue is the clearest way to do that. But to do it without having to implement something for it right now, like the problem is I need to copy the string for the file path also as part of the request. So I need a place to store that. I mean, the easiest way to do that would be just to have a buffer, which is terrible. Okay. Static char 2048. Awful, awful. In fact, this could be way smaller. I mean, come on. Because file paths are not so big anyway. And I'm doing this wrong, I think. Image 1024. I think this is right. Right? Output image path. This is going to be super duper hacky, as always. Has saved. Okay, has saved is what we're looking for. So has saved equals 0. We don't need that one anymore because what we're going to do is say output, what do I call it? Output image path. So output image path 0 is not equal to the null character. Is that right? Oh God. Selector parentheses thing or whatever is giving me grief. Then we're gonna write out to the output image path. Like, this is just the worst thing I could possibly do. And why is it complaining? Undeclared identifier. Why has it got an underscore at the end? I didn't do that. I'll tell you, eglot has got some issues, but I think it's because I'm using an older version, so I needed to update that. All right, so we're gonna save that, and now to say that we've got it done, output image path 0 equals the null character. Come on, delete it. Thank you. Okay, I think that's enough for that. Has saved can now be deleted. Still a hack, but maybe less silly hack. And what we can do now is copy this string. So we can do like a mem copy. No, let's keep it there first. We need to do this first. So mem copy, output file path, and then string length of the file path. That should be enough. What are you unhappy about? I tell you what, it's really hard to write code whenever the language server does not give you correct markers. Output image path. Okay, fine. Output image path. Are you happy now? Satisfied? Cool. As string. So let me double check. Ashraz has an interesting idea. Your event queue could be a list queue of closures to call. Could be, but they're supposed to be executing on a different thread. But yeah, that could work, actually. Nice idea. I like that. We might have to investigate, because if you could just call into a function instead, then that would be pretty awesome. Okay, so we are going to jump to the definition of as number, because I need to make sure I have an as string. As string. Oh, I don't have one? That's lovely. Let's do this then. Value dot as. Wait, what? No. Oh, I have a little buggy bug here, it seems. This should be as what? Dot. Is it bool? Oops. Boolean number object. Okay, so it's object instead. So this is going to be somewhere else, I think. As string. I don't have this. I do have this. It's an object.h. Object string as object. Okay, all right. So I think there's just another issue with that. Let's get rid of that. And maybe, what code was that? That was in value.h. Yeah, let's fix this because it's, oh, haha, there was a reason why I did that. Okay. You can also take that out. I've got something in value.h. I'm right here already, aren't I? I can take Boolean out because that's not needed. So really it's only just a number or an object in that, which is kind of funny. So for the as bool, I'm checking the kind to see if it's nil or not. So I have two separate values, one for t and one for nil, which actually does help with value checking. Yeah, line 20 has an issue, should be Boolean instead of bool. Thanks, Ashras. All right, that's good enough for this one. Let's go back to graphics.c. Now, you don't like this because you say that it's implicit declaration, but I disagree. I think it is there. What is it going to be? Chars? Yeah, so, oh, it's not symbol. It's a string. As string. Yeah, okay. Oh, as C string. I even have a helper for that. So how about that? I don't know why it doesn't think that is available. I wonder if I don't have it exposed through the main header. Let's check that out really quickly too. Go to mesh, go to include mesh.h, VM. What does VM include? Source, VM.h. Okay, that explains it. So it doesn't have object.h inside of it. So if we go back to mesh.h and put in /source/object.h, which is kind of necessary. See you, Jackson. What was the... let's just do this anyway. See what happens. Okay, so it compiled at least. The crash could be because of what we did. It might be for something else. In fact, we didn't even change what the compilation command is yet. So compile, go back to this, what do I call it? Thumbnail. So I wonder if it worked. There's no output unless I log it. Let me log that too. Let's go back to graphics.c. So if we are in output image path, let's log that out. Flux log saving image to path. New line output image path. Let's try it again. So far, I did not see it write anything yet. That's fine. We have not registered the handler. So let me jump to this, copy this signature, go back to flux.h, drop it in right here. I'm just going to leave the external off this time and see if it works. go back to main.c, register this function, render to file, func, render to file. Okay. So we have that now. We're going to rerun it. Let's see. We'll run it again. There's something really freaky going on here. Invalid pointer. Lovely. Corruption. Okay, so maybe I'm doing something bad here. I should probably initialize. Let me go into graphics.c, into the loop. And at the beginning, we need to clear out output image path. I feel like this should already be zeroed out because it's static memory, but just to be sure, we could check this. Output image path 0 equals /0. We need that last slash. Man, come on. That's too many. Okay. Unaligned cache T chunk. Man. Let's take the font loading out for a second. I'm curious about whether this is going to make a difference. I'm very suspicious about the font loading. Saving image to path thumbnail.png. So font loading is doing something bad. I didn't see the saving here though. Let's see. Let me double check. We're gonna write this out right here. So flux log received request to save image. We're at the string path, file path. We're gonna see exactly when it happens. Maybe too early in the game. So it did try to save the file. Maybe there was something wrong there. That seems okay. Interesting how that works. Does it ever save anything? I got a feeling it doesn't. Flux compose. Yeah, there would be like a thumbnail.png there potentially. So the width and the height. Where's that? Graphics.c. I'll just put a new line here. Okay. Height. Cool. I just clean that up a little bit. Let me take out the actual save. Saving image to path. We'll stop calling graphics save to PNG. Just see if it is more consistently operational. Interesting that sometimes it doesn't seem to catch it. I wonder if what's happening is that I'm actually clearing it here because the thread doesn't spawn in time. Saving image to path. Probably happens before the first frame even renders. Yeah, so I'm clearing that out unnecessarily, it seems, which causes a problem with behavior. Well, the first frame should render. Kind of curious why it doesn't work though. Saving image. Saving the window to output image path. It writes it out. It seems to be null terminated correctly because otherwise the string would just keep going. So maybe do I need to give it an explicit path? What was I doing before? I thought it was just output.png. Output.png. Yeah. I was literally just writing out output.png. Well, how about we try that? Thumbnail.msc. We can comment that out. Comments are actually supported. I forgot about that. Output.png. Let's see if that does anything. Jeez. Well, let's debug it. Good. GDB. We're going to load up examples / Was it thumbnail.msc? Run. Okay, so BT rendering window of size to file. Oh, okay, so something else happened here with the Flux log statement. Why? That's interesting. Yeah, libasan potentially. Yep. We'll kill this process and then go back to graphics.c. We'll go to the saved PNG file or function. Oh, wow. Okay, it's not the same file name. That's fine. Output file path. Why did it not like that? Something's going wrong with this print statement here. Let's take it out and see what happens. Huh. All right, so now we'll go back to thumbnail.msc. Let's see if it will actually write out thumbnail.png. Okay, and then we're gonna go to the file browser, and it's right there, and it is the image, so that worked. That's pretty cool. Now, the question is, why did the log statement choke on that? That's really strange. We'll go back to graphics.c. We'll uncomment this again. Output file path. Did I have the right stuff written? I may have to run the debugger one more time to see maybe if it's one of these numbers instead. Huh. I wonder if it's too early. Before one of the, the window size change functions are being invoked. Window size changed. I think this is a problem. It's saving the image before the window gets fully created. So the solution there would be, well, obviously a proper event queue would probably be the solution, but we needed a way to delay this image saving until we know that everything is initialized. So window size update. Window size update. That happens at the beginning. That should have actually been done. Yeah, I think that something is wrong with those pointers, Ashras. Huh. Well, I'm not so worried about that at the moment because it does seem to be working. In fact, if we were to go change which thing we're rendering, let's see if the thumbnail is going to be a problem just because we have an issue with the stupid font config library. I'm doing something wrong there. I think that I'm loading it up wrong. Thumb? Whoa, where's the thumbnail code? February. Okay, there it is. Why are they pointers to begin with? It's complicated. I'll tell you in a moment. Let's see. We got that set up. Oh, which file is this in? It's like thumb. Is this old code? Oh, huh? I think this branch is out of sync. Need to rebase it. Because I changed the code. Yep, that's what happened. Okay, so I'm behind here. I might need to force push this branch. Or just merge it after the stream is over. Okay, that's what I'm going to do. I'm going to rebase. So let's stash this stuff. And we're going to do a fancy little rebase on main. Or master, origin master. Okay, and we're gonna pop the stash. All good. We got a little bit of a conflict here somewhere. Okay, I'll fix that real quick. Emil says, it's complicated, sounds like a relationship status. It is kind of a code relationship sort of situation. All right, has saved. I deleted that. Yeah, I don't want that back. Where's the rest of our stuff? Updated upstream. Yeah, let's get rid of this. Is that it? Looks like it, right? Nope, last one. Preview window. Okay, we got the width and the height here now. Fine. And now it's all good. We can unstage everything. Cool. Now, if I go back into graphics.c, which I'm in, thumb, render the thumbnail. I'll change out the rendering function we're using. And let's see if it renders the thumbnail correctly to the thumbnail.png path. Because it'd be kind of cool. Let's see. I think is it render? What's it called? Save to PNG. Oh, once again, is it the? Oh, no, it's right here. Okay, let's do this. We know now why this is happening. That does not look right, but you know, it's rendering something, so that's not bad. Let's close it. Let's check and see what monstrosity we've created now in thumbnail.png. Okay, so it does render that correctly. I mean, not correctly, but it's rendering the file as requested. So that's good enough, at least to move forward. I'll have to fix that code a little bit before I try to render the thumbnail for the next stream. Okay, so what else can we say about this then? I mean, maybe we could do one last little thing. If I could tell it what to render. So I could do like a Flux harmonic thumbnail function, which is very cheesy, but February 15th, 2022. Well, let's do it for next stream, February 17th. Emil says this project is like OpenSCAD but for images. Haven't heard of OpenSCAD. All right, so if I do this Flux harmonic thumbnail function, I'll go into yeah, this is a cheesy name for function, but I don't really care right now because we're going to do better stuff later when I actually have the ability to create the scene in the language. Flux harmonic, what was it? Thumbnail. And then I'll just name this Flux harmonic thumbnail. Ideally, I would not have to write all these bindings out by hand every time. That's part of what I want to do with the language, is make it easy to generate them. Okay, so we're going to go into graphics.c, jump to the bottom here. Felipe says, OpenSCAD is awesome. I use it exclusively for 3D printing. That's cool. We'll copy this whole thing here. All right. Scripted CAD, where you write code to make 3D models instead of using a UI. Yeah, that's basically what I'm going for, is you know, writing code to do a whole lot of things for multimedia programming. Images, animations, video editing, music, that kind of stuff. All right, so Flux harmonic thumbnail requires a string for the date, whatever. And then we can say this is the date string. And then what we could do is flip the function that's being used for rendering. I mean, ultimately, we need to go back to using our scene data structure for this, which we will do because I think we're finally in a position to do that and actually have it work with the language. So I'm very happy for that, but we won't get to that in the next 12 minutes. All right, so I can leave this in, receive request to render thumbnail, and whatever. We're just, you know, update this a little bit, date, string, and then we're gonna do another little cheesy thing here. Static char flux thumbnail string. Same old deal. So 256, I don't know. I mean, obviously it doesn't need to be that. So how about 100? Doesn't even need to be 100, whatever. And if that one is set, we're gonna switch to the thumbnail rendering function. So thumbnail. So here, if Flux graphics, if Flux harmonic, what is it? What do I call that? Flux thumbnail string? Cool. Yeah, cheesy. Totally cheesy. I could use string length too, I guess, but whatever. Whoops. All right. If it's not 0, we're going to run the thumbnail function. If it is 0, we'll just run the default. Okay. And then in the thumbnail function, we'll use that string as the date function, or the date string. We go down here. Interestingly, the problem seems to have cleared up with the crashing since I moved the stuff around. I don't know why that happened. Flux thumbnail string. Are you happy? No? It's str. Okay, so thumbnail has February 17th. We run the file, completed abnormally. We still need to change a couple things here, I think. File path needs to be changed to date string. And then also we need to add the function signature to flux.h right here. Let's just clean that up a little bit too. Got to delete all these externs. Okay. So now if I run it again. Okay, so it didn't do what it was supposed to. Let's see. What am I missing? What's that 2022 there? Oh. Ah, that's right. Receive request to render thumbnail. Did I copy it to the wrong place? That may be the case. Graphics.c. Yes, I copied it to the wrong place. So I'm going to put this as flux thumbnail string. Run it again. Boom. All right, so we can't see what the... Okay, it is. It's February 17th, even though the whole thing is kind of jacked up. I don't know why it is at the moment, but we were able to describe what we wanted to render using a Mesche file, which is pretty cool. I'm kind of happy that that's working now. So moving forward, we're going to try to wire all this back up to functions that create all the scene objects so that it can be tweaked dynamically. So we can have the preview window open, have a REPL hooked up, which we've already written. We just need to start using it again. And then be able to update the forms we have in this file to see the changes in real time. And then maybe have like a key binding that can send this render to file command to the REPL to cause it to render the file out whenever we want to render it instead of telling it all the time. So ultimately, we will need to have some kind of event queue, which I think we're in a better position to write now because we have all of this functionality. And it may even be something that the Mesche layer could hold on to. Mesche could have a queue that C could access and say, okay, what's the next thing on the queue? That kind of thing. So pretty exciting. I think that it puts us in a good position for whatever we want to do in the next stream, or at least next week when we get back to graphics completely. So I'm excited. I think it's going to be nice. Out of curiosity, let's see what happened to the thumbnail rendering code. I don't know why all of a sudden it looks wrong. I wonder if it's because I changed the scale of the main window. Scale. Let's change this back to 1.5 and see if that helps, because that might be the issue. I may have hard-coded some things incorrectly. No, not exactly. Oh. I wonder if it's because I changed... It's way bigger than it's supposed to be. Huh. Desired size? What are we setting desired size to? Maybe I should change that. Let's go to thumbnail. I want the image to be... Well, hold on. 2500? I had hard-coded something somewhere. Draw texture, logo. Huh. I had done something really bad. Let's see. How do I want to approach this? I need to calculate the right height of an image that's 2500 wide on 16 by 9. Whoops. Let's see. Let's go to the GIMP. Oh, I don't want to run anything right now, actually, because I had EXWM crash right before the stream, and I don't want to invoke that possibility. 16 by 9 resolution ratio calculator. There we go. Here we go. Calculate aspect ratio. I'm sure I could do this myself, but I'm being lazy at the moment. 2500. All right, 1406. So let's try this. 2500 by 1406. I don't know what this is going to look like. It could be terrible. All right, that's actually more accurate. Not perfect, but seemingly better. Let me change the scale. Back in graphics.c, scale is going to be, where are you? Scale, 1.5. Let's go back to 1.0. Run that again. All right. You know, if it happens to render the right size, that'll be good enough. Let's go here to thumbnail.png. Ooh, got a little bit of trash in there. Okay, so we're back in business. I can say whatever I want in that thumbnail, I think. Ashraz maybe found the line. I'll go take a look at that in a second. So we have a thumbnail rendering on demand with a script. So it's not hard-coded. Well, not completely hard-coded anymore, which is great. I'll delete that little file. And then if I go into thumbnail.msc, I can say something like February 32nd, which is obviously not a real date, but we're using it to test to see if the image shows up correctly. And it's February 32nd, so hooray. So we'll just say 17th again. We'll delete that line. We'll go back and just double check the image that got created. That looks good. Cool. And Ashra said scale equals 1700. Yeah, that's probably part of the problem. I'm making some assumptions incorrectly, but we'll fix all of that in due time. I think we're in good shape to fix everything. So I call that a win. I think that we did good, getting basically a new language runtime off the ground in a week, and then wiring it up to the existing code in Flux Compose, and ending up with a better result than what we had in the past. I mean, that was a pretty weird path to get here, but we're actually, kind of where I want to be right now. So I'm super excited about that. So let's check in this code and merge it, I think. I will, let's see, stage all the stuff. Thanks, Emil. I'm pretty happy. It's awesome. All right, so we'll stage all this stuff, all these nasty little hacks here. That looks good so far. Mesh.h, we pulled that in. That makes sense. A little bit of tweaks to value type information. I think the formatter caught us right there. Okay. We want to add both init.msc and thumbnail also as example code because we need to run those again in the future. vm.c, wow. Okay, totally formatted the crap out of that file. Yeah. Oh, well, I like that better, actually. It lined up all the slashes. Seems fine. Okay. My other computer obviously does not have the code formatter set up correctly. All right, and at script.c, we need to delete this code. I'll do that another time. And then main.c is looking good. This can definitely go away now. Whoa, what happened? I'm in the head file. Let's do this. Yep, all right, so now this is clean. All right, so wire up Mesh to Flux Compose and get a basic render file working. And then I'm gonna go to master here. I'm going to pull this over, merge compiler into master, and then push that up. So if you wanna take a look at the code, go check out the Flux Compose repo. Hey, Renan. And take a look at that on master now. It's in the lib/mesh folder if you want to take a look at all the stuff we've been working on in the new language runtime and compiler. We'll go back to our to-do list here really quickly. I think we got that working. We didn't do this, and we didn't do this, but that's fine. We'll do that another time, I think. Maybe in the next stream, we'll work on some of the standard library stuff for Mesh build, and then next week, we'll get more into writing more elaborate code inside of the Mesh files for rendering stuff, because I'll actually have garbage collection implemented by then, and maybe some other useful stuff behind the scenes to work on this. Maybe a queue would be nice too. We're definitely going to need some kind of event queue. All right, cool. Well, I think that's it for today. Thank you all so much for being here. Really excited about the progress we made, and I'm hoping that you're excited about the stuff that I've been working on, because it's all a bunch of randomness in the end, but I think it's fun. So let me know if you've watched the recording and gotten to this point. Let me know what you think about the language and what we've been able to accomplish. And then we'll see you again on Thursday, where we'll pick up where we left off. And until then, keep it creative. See you next time.